Hi guys, welcome to TV Coder channels. For this video, I'm going to show you how do I work on the model serving part for the water quality datasets. Let's get started.
Hi guys, for this video, we will be fully focused on the deployment part or model serving part for our water quality dataset. Okay, so let's get started. So usually the IDE that I will be use is PyCharm. So for this tutorial, we're gonna work on PyCharm instead of Jupyter Notebook. Okay, first of all, let's open up your PyCharm, and we already created the projects. It's called YouTube. So for this tutorial, I'm gonna put all my Jupyter Notebook code and also the model serving code. I'll push to the GitHub later. So under the YouTube folder, so I'll be creating another folder called kaggle, which I'm gonna put all my tutorial series that related to kaggle into this particular folder and push to the GitHub for you guys to reference. Then under the kaggle, so let's create a new directory. So I'm gonna say that this is the water quality datasets. And then let's create a new Python file here, and we just gonna make name it model serving. Once this folder created, you will get a model underscore serving.py. Let's import uvcorn, which is the library that we're gonna use for our fast API later. uvcorn, and then we're gonna from fast API import fast API. Then we're gonna make use of pickles as well because we want to load our model files. And then before we continue, let's create another Python file, which I'm gonna name it as water quality class. Then for this particular class, I'm just gonna from pydantic import base models. There I'm gonna create my class water quality. Then I'm gonna inherit the base models. I'm just gonna create the parameters that we're gonna expect from the REST API or the payload. So the first one will be pH, and we're expecting everything from string. Hardness will be the second one. So we have been created the classes as expected. Then we're gonna go back to our model serving Python folder, and from water quality class import water quality. In order to start with fast API, let's create a variable with called f's. Then I'm just gonna say fast API. For the next one, I'm gonna instant the minimum and maximum value for each of the parameters that we have been getting from our dataset in a pre-processing video. Let's refer back to the particular Jupyter notebook, and let's get the value out from the Jupyter notebook. And we're gonna refer on the value of uncategorized because we at here we are using the models that are uncategorized, so we shouldn't refer to this one which is already categorized, so we won't get the expected prediction output out from this type of max and min value, so we're gonna refer to this one. Okay, let's copy it out. Okay, so we have ready our 9 features that we're gonna use. The 9 feature mean and max values that we're gonna use for the inferences for normalization purpose. What next will be models that we can insert the model, load the models. It should be pcos dot load, and then we're gonna open up the file, which is we gonna copy it from our model 7 here, which is the water quality class model. Then we're gonna copy it and we're gonna paste it here. Open in Explorer. Then we're gonna go in here, and then I'm just gonna paste the model here. Yep, then let's refresh or reload this from this. Then we get our model here, and then I'm just gonna put in the name of the models. Oh, okay, and then it should be read back. Our model are ready. Then I'm gonna start to write my app API. So this will be always the default one. I always like to do this just to let people know your program is working. So I will say is, I will always say if name equal to min unicorn dot run our app, and then let me check app, and then I'm gonna say the port. Oh, sorry. So we're just gonna put in our address, which is for now I'm just gonna show it on localhost instead, and the port will be equals to, let's put it a 9999, and then let's run it just for testing purpose. See whether our app are working. Okay, we're just gonna put in, there's some error here that we're gonna put is host. It's already running. Okay, let's stop this and continue our REST API. So for this particular function or this particular post request, it will be our prediction API. So I'm just gonna put in like slash waters predict. So what does this mean is if any request come into the localhost port 9999 with the URL of waters slash predict, so it will come into these particular functions, and the function I will just call water quality. I'm just sorry, water quality predict. For this particular request, I'm gonna take in a parameter, and the parameter should be the water quality class. Should be the type of water quality class. And that, okay, the first things that come into these particular functions, things that we're gonna do is we want to convert our request into a dictionary. So it will be in a payload type of JSON, and we want to make it to a dictionary form. So I'm just gonna say data dic or data the dic. I'm gonna instance my features one by one. The first things that I'm gonna get out from it, it will be the first. I'm gonna make it into a float type because all our requests is in string. So we're gonna convert it to float because we are gonna working on float data type. So it should be data dic. Then we get the ph value out from the dictionary. So yep, ph value out from dictionary. And that what we're going to do is minus the ph mean, which we want to start to normalize and compress the incoming so-called features value into the scale of 0 to 1. Then I'm going to just divide pH max minus pH min. Then this is our pH first feature. The second one will be hardness. The same thing I'm gonna do. Once that is the call of post coming with this URL, then I'm gonna expect there will be a payload here, and I'm gonna convert it into our data, which gonna match to our water quality classes. And then I'm gonna take this particular data, a payload, and convert it into a dictionary. So I'm just gonna extract it out one by one, and I'm just directly normalize it, and this will be our inference features. I'm just gonna say inf features. It will be right, so features. Sorry, it should be pH. Then hardness. Then solids. Chlorines. Sulfate. Conductivity, organic carbon, organic carbon, trihalogenous, and then the last one will be turidity. And then we're going to see our result will be models dot predict our inference feature. So once I get my feature inference, so I'm going to say that equal to result dot to list, and then I'm just going to take the first value, which we only have. We are doing single prediction, so we are not gonna have many other values. So this 0, that is typo. And then we're gonna shape our response output as well. It should be in a dictionary form. So I'm gonna just say that predicted quality, I would say. I'm gonna create another dictionary, so I'm just gonna say that predictions classes dictionary. So let's refer back to our water quality. So we will refer here. 1 means potables and 0 means not potables. So we just gonna say that the response output should be prediction classes, and based on the results that we get out from the model, then I'm just gonna return the response. So seems that we have been ready for our inference code. So what it does, so first of all, I'm gonna import all the required libraries, right? And then I'm gonna create a classes that it should correspond to our inference or payload that we are expected the user to send in. And then what I'm doing next, I'm instantly pass API as our applications. Then beforehand I start to develop anything, then I'm just gonna record down all the max value and mean value for each feature that I'm getting out from our original dataset that we trained for it. Then I will be loading the models, which the best models that we trained from our modeling video, which is around 71%, that are trained on the uncategorized dataset, water quality datasets. Then I need to create another reference dictionary. Then this is the functions that it's always the best practice to have, just to make sure that everyone that visit this particular URL, we will get the response message which indicate our apps are running fine. Then this is the main post request that we're gonna use for our inferences. So I'm just name it as water quality predict. Then expect to have the payload come in. So I will just name the parameter as data, and it should be in the type of water quality. Then the first thing, I'm just gonna convert our payload into a dictionary form. Then I extract each of them out from the dictionary. Then I'm just directly normalize it with the values that we have pre-installed here. So after we have been completing this, then I'm just gonna make this into a two-dimensional array. Then after that, I'm just gonna run the model prediction by calling model.predict. Then put in our inference features. Then we should get the result. And once getting our result, is also the output type of our result should be in numpy form. So we want to make sure the result is in the list form, and then we're able to extract the first prediction out, which is the only predictions that we have, because we only have one dimension of features, right? We are not doing batch prediction, but instead we are doing only single prediction. So it should only have one, and it should be in the index 0. Then after we get the result as a scalar, then we want to check our response output as well. So this should be, I will say the key will be predicted quality, and then the value should be referenced from the prediction classes dictionaries that we have installed, right? So we will get the corresponding output here from here. So if this is class 0, right, so we should get a not portable, and if it's 1, then we should get a portable. Then we will return this and send back to the request user. For next, we want to test our app whether it's working, so we're just gonna run this model serving Python script. So now our app is running. Just a quick one, we just test whether is it running. Yes, it's running now. So in order to test this, I'm gonna open up my Postman. Before this, I have been released all the URL and also all the payload. So just have a quick explanation here. So for this Postman, we just put in the URLs that we're gonna send our request to, which is the HTTP. We can refer to here HTTP 127.0.0.1, which is meant by our localhost. So then port 9999. Yep, it's port 9999. Then our /models and predicts. So it should come to these particular functions. So for these particular features, I'm actually referencing from the water portability CSV, which is our original data set. It should be in line 21. So I'm just copy all the values here, and we should expect the classes predicted should be 0. Okay, let's send by clicking send to our models to see how it does. Okay, there's something wrong. Okay, there is some typo error here. Okay, let's stop this and rerun again. Then we just come back to here and send again. So we get our response back, which is predicted quality is not portable, which is come to here. Not portable is class 0. So if you refer to here, correct for this particular one is class 0. So yeah, we have been successfully completed all our water quality data sets, from the data understanding part into the data preprocessing, and then come to the modeling and then model serving part. So until here, thank you for watching. So I will be putting all my codes into the GitHub, and I will put the link in the description below. If you like my video, please help to click the subscribe button and also like these videos. Thank you for watching. Bye bye.